Time for note card number 70, almost all the way through. We are at area with respect to y. So up until now, we have been doing area with respect to x, which means that we have been thinking about our boundaries in terms of x. So thinking about where they intersect at our x values, making this a and this b. And we've been thinking about doing the whole area minus the bottom area, right? So the top minus the bottom. So we've been working with this. So the integral from a to b of, if I'm calling this top one f of x and this one g of x, f of x minus g of x dx, okay? And then we've been integrating that way. So this is a very, very similar process, but instead of doing the top minus the bottom, we're gonna be thinking about it in terms of the right minus the left. So we're gonna be thinking about almost like if this was sideways, like that. Okay, so we're gonna do an example so that you can see what we're talking about. So example number 1, actually the only example on your note card, says consider the curve y squared equals 4 plus x, and the chord, which is just a chord is a straight line connecting 2 points, chord AB joins points from -4 to 0 and 0 to 2 on a curve. So first I'm going to draw what that looks like. I have got this right here. I know that if I did this, right, if I got y by itself, it would be the radical sign. So if you're not sure what this looks like, you can just plug in points. But looking at this, I know that -4, 0 is going to be an intercept, right? And then it's going to curve up this way. And at 0, I would have 2, right? Which conveniently is my chord as well. So I did not draw that well. Hold on. I'm going to make that a little bit more curved for us. And then we have a chord connecting it. So we've got like this little slivery thing happening right here, okay? So because y is not by itself, we got y by itself, but up here, we are going to actually practice using integration in terms of y using this example here. So when we integrate in terms of y, it is very similar, except we have the integral from c to d, where c and d are my y values. So normally I do my x values, right? My a and my b are on my x-axis. I'm gonna think of it in terms of c and d, and instead of doing top minus bottom, I'm gonna do the right minus the left, okay? So I don't have an equation for this. I can do that using algebra. So I'm gonna come over here to a little sidebar situation. And I know that I have y minus 0 equals my slope, so I could do my y minus y, 2 minus 0, 2 minus 0, sorry, over 2 minus 0 over 0 minus -4, be positive 4. And then x minus, I used this point here, so x minus -4 plus 4. So I have y equals 1/2 x, and then that 1/2 gets applied to this plus 4 and gets plus 2. Okay, so that's my equation of my line, of my chord. And I'm keeping it, but I want it in terms of both of these in terms of x, so I want to rearrange both of these. So I would have, instead of doing this, I would instead do this, x equals y squared minus 4, which is going to be easy for us to take the antiderivative of. And then this, I need to get the x by itself, so I'm going to do y minus 2 equals 1/2 x, multiply everything by 2, and I get x equals 2y minus 4. You see that there? Yes. So I want my right minus my left. So if I'm looking here, my curve is on the left, my straight line is on the right. So I want my straight line to go first, so this 2y minus 4. So notice, because I'm doing this in terms of y, I'm going to have y's in my integral. Minus, my left was my curve, so y squared minus 4 dy, and then I have the integral from, I want my heights. So looking at my y-axis, I'm intersecting at 0 and at 2, at a height of 0 and a height of 2. Now I can simplify this and use all my normal rules. So I've got 2y, I've got minus 4 minus -4, so those will go away, and then minus y squared. Have not taken the antiderivative yet, I just simplified. Now I'm going to take the antiderivative and get y squared minus y cubed over 3 from 2 to 0. Now I can plug those in, oops, sorry. And I've got 4 minus 8/3 minus, and I plug this in, I'm going to get 0. So then 4 would become 12/3 minus 8/3, and I get 4/3. thirds is my answer. Okay, so this is one way that we could find this area. So some of you might be wondering, well, could I have done this in terms of x? Yes, you could have. You just would have had to get this y by itself, so you would have had y equals the square root of 4 plus x, and then we would have kept this one here. They're just a little bit more complicated of equations. So our integral work would have been a little bit more advanced over here, but that's okay. You could have done that. But that's kind of the purpose of why I chose to do this in terms of y, because I avoided taking that square root and having to use fraction exponents, and I was able to make this pretty simple down here as well. Okay, so you can do it both ways, and if you want to try it doing in terms of x, you'll see that you get 4 thirds. We just chose to do in terms of y because it eliminated the need for us to use a square root sign here. Okay, and we had a very clear picture where we could tell clearly that the curve was on the left and the line was on the right.